Hello, and today I've got another puzzle for you that comes in recommended by Marty Sears, and that is his puzzle Friend Zone. This puzzle's already been featured on Cracking the Cryptic, which I'm a little hesitant to wade into because I don't want to draw that comparison, but I think it's inevitable, probably. So uh, let's see. I mean, they've already done a number of puzzles that I've already done. And so, people already know that they're much better solvers than I am, so it's fine. Uh, let's see. What are the rules? Normal Sudoku rules apply. Uh, these cages are going to have some total in them, so I'm going to fill these with digits, maybe 1, 2, 3, 4, 5, right? And then this would be the total. This would total 15. And if I have two cages, let's say these two cages that both sum to 15, how would I do that? Let's call it 1. 2 is 3, need 12, 3, 9 maybe. Then these two cages, both summing to 15, are cage friends. And what's going to be true is that the circles in these cages tell you how many cage friends that particular cage has. And then the last rule is that these colored cages, blue, pink, and purple, have no friends, set face. And I like that writing, so thanks, Marty, for the puzzle. We're going to try it out. I'm going to click restart the time and see how it goes. So, this cage is huge, so I'm immediately drawn to this huge cage. And the smallest this cage could possibly be is 28. That'd be the digits. The sum of the digits 1 to 7. And further, this cage has a circle that sees the circle of all these cages. And why is that important? Because now they can't be friends if their circles see each other. So why is that? That's going to be true because being friends is transitive. What does transitive mean? So let's call this cell cage A. Well, let's not put it there. Let's put it in the middle or in the top left corner as if it were a cage total. Let's call this cage A. Well, cage A is going to have some friend total. I don't know what that is. It could be 28. It could be much higher than 28. So it's somewhere between 28 and 42. And cage A has at least one friends because this digit can't be 0. So let's say that this is also cage friends with A, right? Now, if that's true, that means these two have the same total. So actually, I'm going to call this cage B. So A and B are friends. So now that's going to put a lot more restriction on what cage total can be. But let's ignore that entirely just to demonstrate another principle here. Now let's say I have a third friend, cage C. Let's call it this one, cage C. Now let's say I know that A and C are friends. Well, if A and C are friends, that means they have the same cage total. If I know A and B are friends, they have the same total. And since, equality of sums is transitive, then the sum of A is the sum of B is the sum of C. That means B and C are also going to be cage friends. So however many cage friends A has, B is going to have that same number. And so their circles are going to have to show the same value. Right? That's going to be the transitive property of cage friendness, which means cages with circles that see each other definitely can't be friends. They definitely can't be friends. So this cage is not going to be pretty restricted on what it can be friends with, right? It can't be friends with any of these because it's it sees those circles. I don't think it can be friends with these because they're just too small, right? So the smallest this can be is 28. The most this could be is 24. Maybe 7, 8, 9. And these are even smaller. So this can't be friends with anything in the bottom. The only thing it could possibly be friends with is up here, these two cages. But it can't be friends with both because they see each other. And so these two cages can't be cage friends. So this is a 1. We have a digit. Our first digit is a 1 in the center. 1 in the center. So this is exactly one cage friend. And it's one of these, but I don't know which. What next? So I've got some cage well, I have pseudo cage friends. What's going on with these rows and columns? So before I say it, let me make sure it's true. I think it's true. Uh, so I'm thinking that these totals are gonna basically determine how many groups of cages there are, right? So let me back up one step. So this cage is gonna be friends with one of these two. I don't know which. Let's say it's this one, right? So we'll call those the orange cages. That's one friend group. Nothing else. I mean, I've already shown that, this is not going to be friends with anything else. But the fact that these two are cage friends and nothing else is going to be friends with them, that's going to kind of propagate through. So let's say I had these three being cage friends. All right, that's possible. So let's call those green. And then I have maybe these three being cage friends. Maybe these three being cage friends. We'll call those red, and these two being cage friends. I mean, it's not going to work, but we'll suppose that that's the way that the friend structure worked out. I basically have these non-overlapping groups of cages with the same total, right? So the greens all have the same total, which is different from the oranges, which have the same total as each other. Those two are both different from the reds, which have the same total, but different from the blues that have the same total. Now, what's going to end up being true is that the blues all have the same number in their circle. The reds have the same number in their circle. The greens have the same number in their circle. So why, I mean, this one doesn't have a circle, so that one's kind of special. Why is that important? Well, so what's the smallest I can make this? Is 2, 3, right? So what does that mean? Well, that means this, if they have, so another thing that's going to be true is that if you have different numbers here, you definitely have different cage sums. You're not friends, right? Because we said before that if you have the same friend total, then you have the same number. So the contrapositive of that is also going to be true, right? So if you don't have the same number in your circle, you're not cage friends. So, so these three are not cage friends with each other, and they're going to set up kind of three distinct groups of cages. Same thing up here, right? And the kind of smallest number of cages I could possibly wrap up in that is 9. Why 9? This cage with one friend, I don't know which it is, let's say it's this one still, that takes up 2 of the cages. Let's say this was the 2. It would have 2 other friends. I don't know what they are. Maybe it's these 2. That's 3 more, but whatever ones they are, that's 3 more cages. And this would be 3. That would be 4 more cages, right? And then if that were the way it went down, if that were the way that this puzzle actually wrapped around, it'd actually break, because if these were 2, 3, it breaks the puzzle. Because what I'd be left with is exactly 1 cage. I don't know if it's this one, but in the hypothetical grouping I made, it's this one. But if these are 1, 2, 3, those 3 circles would show us 3 of the friend cage. Oh, sorry. Whatever these numbers are, this shows us 3 of the friend cage groups. If it's as small as possible, that's 9 cages, right? And then I have 1 left over, which wouldn't be able to pair with any of the 9 that are done, so that would break. So the only way this works is if I make this a little bigger, right, and make it 2, 4. I'm just making sure there's no, right, I can't have, it's just the only way it can work. I'm trying to think how to describe that in a rigorous mathematical way. I'm having some trouble. But basically, so I know that it works this way. 1, 2, 4 is going to be a group of 2 cages, a group of 3 cages, a group of 5 cages. That'll sum to 10, which is the total number of cages we have. But there's also no way to dissect it another way, where these are 3 different groups of cages, but there's a 4th mysterious cage, right? Because again, this is the smallest it could be is 1, 2, 3. That leaves exactly 1 left over. I can't get any smaller to get more left over to pair that cage with something. So I'm 1, 2, 4 here. That means this is also 1, 2, 4 by the exact same logic. And so what I'm going to end up with is some diagonal pair of these cages paired with each other. That'll be a 2. And then those are going to pair with something else. Actually, all these circles are 1, 2, 4. One of these is 1. These are not 1. So these are 2, 4. I'm trying to think if I can say this isn't something. I don't think it can be 2, right? Because this is 1, 2. Oh, if one of these is paired in the group with 2 friends each, let's say it's this one again, then this could pair with, say, these, right? And then, yeah, all these would have to be 4. That would make these 4. That would make these both 4. So these can't be 2. These are 1 or 4. These are 2 or 4. So my group of 3 cages, which have 2 friends each, is going to be some diagonal pair of these even boxes, the box 2, box 4, box 6, or box 8. And then one of these down here. So not this one. So this is actually a 4. This is actually a 4 in the group of 5 cells, which each 5 cages, which each have 4 friends. So maybe I should color that. So let's call that orange. We'll call this green. And then 2, when I get there, we'll call that red maybe. Trying to get maximum differentiation from these. So, what next? Well, let's think about. I think this one maybe can't be 1. Yeah. So this can't be the 1. So if this is 1 and it pairs with this, then the smallest of this cage can be, the 1 could go with 7, 8, 9, and then this would be 25. But the smallest this can be is 28, and the largest this could be is 25 if it has a 1 in it. So that doesn't have a 1, it has a 4. And so this is now an orange cage along with this one, and this is a green cage. And now the largest this can be is 31. The smallest this can be is 28. So the largest this can be is now 31. Because the smallest this can be is 15. No, 14. 5, 6, 7, 8, 9 is the smallest it can be. The smallest digit I can have in these cells is 5. That would happen if it's 5, 9 with a 14, and then this would be 31, and this would be 31. Okay, maybe this is at least 10, because the smallest these 4 groups can be, one of these is a 4 group, and the smallest that can be is 10. Oh, this is 2, this is 4, just by sudoku. So now I've got another orange cage here, that's red. We said I'm going to define the ones with 2 in their circle, so there's 3 of them, will be red. What else do I know? I know. Well, I know this is fairly small, right? The largest it could be is 13. In fact, this is at least 10, we said, right? This is at least 10. So this is 6, 7, 8, or 9. And this is at least 10. But it could be 10 exactly. I could have 1, 9. What is my next step here? What is my next step here? I'm wondering if this can't be 2 for some reason, because, right, the smallest, the 2 group, because one of these is a 2, right? Because they can't both be 4. So one of these is a 2, So in the 2 group, the smallest that could be is 10. And so if this were a 2, this had to be 8 or 9. And yeah, it couldn't even be 9. It couldn't be 8 rather. It'd have to be 9. Because this were 2, 8, then one of these would have to sum to 10 with a 2 in it. Well, this one can't because it'd be 2, and I would need 1, 3, 4 here to get to 10, but the 4 breaks that. Here I would need 1, 3, 4 here as well. 1 and 4 see both of these, so they have to both go here, which breaks that. So this is a 2, it has to be a 9. But I think that works, right? I could have 2, 1, 3, 5, or 2, 1, 3, 5. Either way. The reason it can't be a 4? There is a reason it can't be a 4. Okay. So this can't be a 4 actually, because if this is a 4, this is also a 4. These have to have the same sum, which means this is the same as this, which breaks the row. So that actually is a 2. And that's a 9 for the exact logic that I just outlined. That's a 4. And so now one of the, I don't know which still, is 11. And this is 11. No 4 or 2. It's either 1, 8. Because these chips in the 9. So either 1, 8, can't be 2, 7, 3, 6, can't be 4, 5. Because 4 is seen by both. Both of these cells see a 4. Okay. What now? What now? What now? Now this 9 sees this. So now this can't be a 5, because the 5 need to be a 9 with this. Does that's got to put some pressure here. Right? So the largest this can now be is 15, which means the smallest this can be is 30. So this has to have 9, 8, 7, and either 5 or 6. Right, because this could be 29 with 1 is 30. Yeah. And then 4 has to go in here. That's a 4. And then 2 and 3 have to go here, but I don't know where. Maybe it's this, right? So this is at most 13. Oh, so this has to have a 1 in it. I was thinking that this could be 9, and therefore it could be 2, 3, 4, but that would be 2 4s in the cage. So if this cage is at most 13, then it can't be 2, 3, 4, 5, because that would be 14, which is bigger than 13. So it has to have a 1 in it, but this one tells me where that 1 goes. So that's 1. That's not 1 or 8. There's a 1 down here. What else? What else? So what can this be? This could be 2, 3, which makes a 6. It can't be 2, 4, so this can't be 7. It can be 2, 5. That makes this 8. It can be 2, 6, or 3, 5 to make that 9. That's a lot of options. That's a lot of options. I'm wondering if for some reason this can't be 6, because if it's 6, well, if it's 8 or 9, then it goes here in this cage. Not that super helpful. At least as far as I can tell. 2 goes up here by sudoku. This is the same sum as this? Is that? I don't think that. I mean, there's too many choices. I was thinking that might put some restriction on what can be here, but this is somewhere between 19 and 25. So Not too impressed. This is not 9, actually. Because of that 9. So this is now not 6, and it has to have a 2. What can this be? This is either 6 or 8. But it's not 6. Okay. So this is not 6 because what... Sorry, this orange cage entirely is not 10, meaning this pair is not 6. Why not? Well, it can't be 2, 4, because that's a 4. It can't be 1, 5, because 1 sees both of these. So this can't be a 6. It has to be an 8, making this a 2, 5 pair. That's not 5. This is 8. So what can it be? It can't be 1, 7, because it can't have 1s. So it's either 2, 3, 5, 6. This can't be 2, 5, so this can't be 3, 6. I think we said 8 has to go here, 7 or 6. So if this is 13, then this is 32, which is too big. Yeah, so you have to do an 8 here. What's left here? Too many choices. Where does 1 go in this? Oh, sorry, 1's right there. What is the next step? 4 is here. Well, it's got to be a 9. Yeah, it's just... So I have 2 and 4 in the corners. By this 2, 4 pair. Just not seeing it. One of these is a 2, and that's going to go with 1, 3, 5. I'm trying to think of a reason that doesn't work for either one in particular. So if this is 2, we get 1, 3, 5. If this is 2, we get 1, 3, 5. Well, I know this 4 sum is now 12. So if it's 4, how do I get a 12? I need 8 more without a 4. So it's 1, 2, 5. This can't be 4. This one can't be 4 because if this is 4, I would need 1, 2, 5 here. The 2 is there. So that has to be the 2. This is 1, 3, 5 without a 1 there. This is 4 with 1, 2, 5 here. The 1 has to go here. The 2 tells me which way that goes. So now I've got a 2 up here. 4, 4. What's out here? 3, 6, 7, 8. 3 in the high digits. But I don't have any of the high digits anywhere, so I don't know how to do that. So I'm thinking about why this purple cage is here, because and I don't know Marty Sears well, but I know him enough to know that, well, that's a 3. Hold on, that's a 3 by this 5. But I know him well enough to know that if there's no extraneous clues in this puzzle, right? So this has to do something. But none of these cages, none of the friend cages have a total of less than 10. So there's really no restriction at all on this purple cage. Obviously, I wouldn't use this logic to like actually exclude things, but it might help me know where to look for something. So I guess what's going to have to happen is this cage, one of these cages is going to be less than 10, and therefore conflict with this. That's so far beyond where I am in this puzzle right now. So let's focus on what I can actually do. Mostly just stalling for time while I look for something that I can see. Oh, this 8 sees those. So I have 8 in here. I have 8 in here. What's here? 3 in the high digits. So 8 is here. 8 is here. 8 is those. 1 is here. This is 12. So it's either 3, 9 or 5, 7, but not that way. This is not 12 or 11 or 10. Let's see, I can color those for completeness. So it's either more than 12. But it can it be more than 12? Yeah, it can be 7, 9. No, it can't be 7, 9 because I would break this. Can it be, let's see, if this is a 9, we get 5, 7 here. 9, 8, 7. 9, 6 is 15. I could have 9, 6. Okay. So it could be big. It could be pretty big. Actually, 9, 6. That's 9, 6 here. 9 is 9 here. 6 here. That would just work. Okay. What is next? 1, 1. That's a 1. Wait, why can't 1 be up here? Did I make a bad pencil mark? Well, no, 1 is not there, so 1 is here. So now I have, even if I mis pencil marked it before, it turned out to be right. 1, 1, that makes this a 1. No, sorry. The reason that 1 pencil mark, I have a 1 here already. So that's why this 1 pencil mark is here. 1. Where are my 1s? Here. Any of those, yeah. I'm trying to see if I just need to do some sudoku. That's not 2. That's 2, so that's not 2. That's 2, yeah. It's just sudoku. That's 2 because I've got this 2 marked here. 2 is down here. This is a 1, 2 pair now. That's 5. Oops. 5 and 3. That's not 5. I'm starting to think that, well, it can go one of two ways. Either we'll find out that this has to be 30, in which case that has to be the 5, or we'll find out that can't be 5, and therefore this has to be 31. I think one of those two things is going to happen. We'll see which one. These are all high digits. Whatever this could be 5. No, it can't be 5 or 1. So whatever this digit is goes here. Don't know if that's helpful. I'm sure, well, it's not helpful right now to me. 2, 2, 2, 5, 2. 5, 5. One of these is a 5. 1 makes that 5, 1. This one does. 5, 5. We got 5 up here. So it's a 2, 5 pair. Unexpectedly, but I know which way it goes. 2, 5. 1, 2. So 1 is now here. 5. No, I already know that. Let's see. This can't be 9. This is the higher. This is the lower. What is this? 3, 5, 3 or 6. What are these? These are 5. One of these is 5, not 1,000. So that's 5. This is 6 or 7. 5. 5 is one of these. That's not 5. 5, 5. 5. Oh, 5, 5. 5 goes here. That has to be a 5. So that's not 6. This is a 7, 9 pair. And that tells me that, so this is now 30. So this is 15. So that's 8, 7. That's 6. That's 7 or 9 because it's not 8. The other one goes here with this, and that leaves this being only 6. So 6 has to go here. What's this? This is a 3. 3 is in one of those. Other missing digits in this row are 7 and 9. Other missing digit here is 6. This is this one. Okay, 3 goes in one of these. 4 with a 4, so that's a 3, 4 pair. That means this is 6, 9. This is now 8, 7. I need 7 here. That's interesting. 6 is also here. 6. Now I know this is right because 5, because of this 5. 3, 9, that makes this 7, makes this 8, and the remainder is 3, 9. Do I know which way that goes? Not yet. And then left here is 5, 7. 1 can't go here because if it did, that'd be 5, 7. That would be 12. And that would be friends here. This has no friends. It's a very sad cage. And now this will be less than 10, which will put pressure on this purple potentially, or vice versa, I guess. That's a 7, actually. So that's just a 6. This can't total 6. This can't be a 6. What can this be? 1, 2, 3. Could be 4. Could be 5 or 6 because of this cage. Could be 7 or 8, I guess. So not yet, but that'll come. What's left here? A lot. What's left here? 4, 8, 9. It's not restricted anywhere. That's not 3. That's not 1. That's 6. 3. That's 6. So I didn't do anything for that. Right, because I didn't use this to get that with 6. That's 8, 6. That's 7. 8 is one of these. 1, 2, 3. What's left? 4, 6, 8, 9. 6 is down here. I don't know anything about the rest. There's too many digits here. 7 means that's 8, 7. That's not 8. So this is actually 6, 8. That's 9, 3. So what do you mean by there's too many digits? I saw that there were like too many digits for the givens that were left. Like the number of possible squares for those digits to go was too many, so I had to look for what was given to eliminate the possibilities. This isn't 3 by this new 3 here. So that's 3, 4, 6, 7, 8, 9. 6 goes here in the column only. 8 goes in one of these, but I still don't know which. I don't know here either. I feel like we're well, this is 7 or 9. That's 9, 7, 9. There we go. 9, 4, 9. 6, 8, 9. There's one more 6, 7, 8, 9, and one from 3, 4. Not 9. What? It can be anywhere. What's here? 1, 5, 6, 7. These are from 1, 6, 7. This is not 6, so it's from 1, not 7 either, so that's 1 or 5. Delete those. I don't think I need them. 1, 6, 7, 1, 5. Hopefully there'll be some pressure here, or else this can't, no, this can't be 1, 5. I was thinking these were boxes that saw each other, but actually this can't be 1, because this would be 1, 5. I would make that 6, so that's not 1. If this is a 5, I think this purple cell is useless. So I think that's 1, but I don't know how to prove it yet. 1, 1. I don't see it. 6, 7, 8, 9. So this is 1 with 3 or 4, but that's not 3. What's over here? 6. The other 3 or 4 This could be 8. This could be 8. Well, there's no 9. Well, either of these can be 9. Any of these can be 9. What am I missing? I'm sure I'm missing something simple. But, so one of these is 3 or 4. If it's 3, it has to go here. If it's 4, it could go anywhere. And the other one is 8 or 9. The other one is 8. 8 is here. That's not 8. That's 8. Now I have this kind of 7, 9 pattern. Do I have to color them? Or can I just see where it goes? These are also 7s. Yeah. So this is this a deadly pattern? Did I break the? No, I won't break the puzzle because this will be restricted. This is, I think, otherwise a deadly pattern. So 8 with either 3 or 4. This one's not 3. This could be 1 8, right? 5 with 4 or 7. Yeah, that's fine. What goes here? What goes? I know this should be done to 2. So it's 8 or 7. But not 7. 8, 7. So this is a 7. So this is gonna be 1 7. I'm sure of it, but I can't prove it yet. So this is 1 5 4. 1 5 4. That's 8. That's not 5. 1 3 4. What is going on here? Oh, it can't be. Okay, this can't be 5 because of the 11s and 12s. I was so focused on getting this to the purple, I didn't think about the other cages. So this can't be 5 because 5 6 would be 11. That would go with reds. 5 7 would be 12. That would go with this. So that is a 1. And this can't be 6 now because that would be 8 pairing with the purple. So that's 7, 5, and then this is all just gonna deadly pattern away. Right? Please say right. 1 3 4. I think I did it. Aha! Excellent work. Thank you, Marty. Great puzzle. This was a lot of fun. And again, I think like a lot of your puzzles, really thinking in a different way than I've thought before. So I appreciate that. Thank you for watching, and see you next time.